Shivanjay.
शुरू से
A very warm welcome to one and all present here. Today we are here for the video presentation of our major project, which is based on Chatbot ASPA. Chatbot ASPA, the full form of ASPA is Authentication Service Provider Associate. First of all, I want to introduce my teammates. Myself, Aniruddh Lingayat, as a team leader. Our second team member is Shivanjay Mahanoor, and third team member is Karan Dahayat. Here are some certificates of our projects. Now we come to abstract of our project. A chatbot is an artificial intelligence system designed to stimulate human conversation through text or voice interaction. It operates based on pre-programmed scripts and advanced machine learning algorithms, enabling it to respond intelligently to user queries. Chatbots are widely used in customer service, virtual assistance, e-commerce, and various industry to automate interaction, improve efficiency, and provide 24/7 support. Here are table of contents of our project. Now we come to the first chapter of our project, which is introduction. What is a chatbot? Chatbot is a software application to design to stimulate human-like conversation with users, primarily through text or voice interaction, utilizing artificial intelligence and natural language processing. Chatbots are understand user queries and respond in a way that mimics human conversation. There are system requirement specification, purpose and scope. First of all, purpose. The purpose of the SRS document is outline the functional and non-functional requirements of the development of chatbot system that will provide customer support engagement of an e-commerce platform. Second, the scope. The scope chatbot will assist. This chatbot will assist user to product inquiries, order tracking, and general customer service queries. Now we come to the second chapter over, which is project planning. Project planning development approach. First, we read objectives, define the purpose of goals of chatbot. Now, stakeholder identification, identity by the stakeholder, including project sponsors, user, and team members. Second, planning, technology selection, choose the appropriate technology stack, including chatbot, frameworks, the Flow, Microsoft Bot Framework, and programming languages. Third, design, the user design, create user person to represent target users. Technical design, define the architecture of the chatbot, including the backend system, APIs, and integration. Create documentation outlining chatbot functionalities and technical requirements. Development, the development is development task. The build the chatbot's backend, including the intent recognition, response, regeneration, and integration with the external system. Testing, uh, conduct unit testing for individual components, perform integration testing to ensure all paths work together smoothly. Now we come to the software process model. As we can see, there are three phases in software process model. All three phases of different activity, which is modifier knowledge base, modify model training, model testing, model release, model conversation, and analyze metrics. Now we come to the third chapter, which is system requirement studies. As we know, the chatbot works on the natural language processor. Natural language processing is technology that allows chatbot to understand and respond human languages, both spoken and written. Now come to the hardware and software requirements. Processor, dual core processor, 2 gigahertz faster, RAM 4 GB, 8 GB, storage is 20 GB free storage, network, stable network, internet connection, minimum 10 Mbps or hosted bots, advanced AI chatbot. Processor, multi-core processor with high clock speed, RAM 16 GB for smaller NLP, models 32 GB plus for large models. GPU, dedicated GPU, AI training or interface. Storage SSD with at least 100 GB free for model storage, more if training data sets are large. Cloud development use scalable virtual machines like AWS, GCP, or Azure for high demand. Development environment programming language Python, JavaScript, framework libraries Python, TensorFlow, JavaScript, and IDEs and editors VS Code, Python Charm, and Jupyter Notebook. Now we come to the chapter 4, which is system analysis. System analysis for chatbot involves a structured approach to understand the chatbot's purpose, functionality, requirements, and how it fits into the broader organization of business ecosystem. The process ensures the chatbot meets user need effectively and elegance with technical, functional and business objectives. There are some points to understand problem domain goal of chatbot. Target audience, end user, internal stakeholders, expected benefits, reduce human workload, provide 24/7 availability, improve user engagement and certification, requirement gathering, functional requirements, answer user queries in natural language, perform specific tasks, integrate with third party, multi channel support, non functional requirement, usability, performance, scalability, security. Third, feasibility study, technical feasibility. Evaluate the tools for the technology required, NLP tools, frameworks. Assess existence infrastructure. Can current server handle AI, ML workloads? Is cloud computing? Economic feasibilities, cost analysis of chatbot development, deployment, and maintenance. Estimate ROI. Operational feasibility assesses if the chatbot aligns with business processes, evaluate and user adoption likelihood. System design, consideration system scope, define the chatbot's boundary, type of queries it will handle, level of complexity. Architecture, front end interface for user to interact with the chatbot, backend, NLP engine, database, and logic processing, integration, APIs for connecting with the external services, flow design, map out user interaction, use flowchart to visualize conversation path, define fallback mechanisms for when the chatbot cannot answer, risk analysis, identify potential challenges and solution, fundamental requirements, platform compatibility, non-functional requirements, feasibility studies. Feasibility studies now come for feasibility. Feasibility study for chatbot assesses it practically and viability across various dimensions to determine its potential for success. Technical feasibility examines whether the existing infrastructure tools and expertise can support the development and deployment of the chatbot. It evaluates the availability of NLP frameworks, integration capabilities with existing system, and whether on-premises cloud hosting is more suitable. Now, I hand over the fifth chapter to the team member Shivanjay Mahanoor for explaining the fifth chapter.
In chapter 5, we have a user case diagram. Use case. User case. A use case is the context of chatbot, refers to a specific interaction between the user or a system and the chatbot that is designed to achieve a particular goal. In outlines, the system involves a fulfilling a user request or task. A user case could involves a customer in interacting with the chatbot to authenticate their identity after while the chatbot answer their frequently asked question. Provider products recommendation or tracks their order status. If the chatbot is unable to resolve the issue, the use case will include executing the query to a human agent. Another use case might involve in administrating, updating the chatbot knowledge base, ensuring the bot remains accurate with new information. In chapter 5, there is also a topic class diagram. In a class diagram for a chatbot system provides a structural view of the system by illustrating the key components, their attributes, methods, along with their relationship between them. The central class is the diagram in the typically the chatbot, which manage the conversation flow and ostrich communication between the user and the system. This class is responsible for interacting with the user, processing their request, and sending appropriate response. It might have method like process request to handle incoming user input and send message to return the chatbot reply. Connected to the chatbot, class is the user class representing the end user who interact with the bot. The user class holds information like users, credentials, and preference, and its method may include authentications user for verifying user identifications and many more. In ER 5.3, there is a ER diagram. ER is an entity relationship diagram for a chatbot. Is a conceptual representation that models the system key entities, their attributes, and their relationship between them. At the center of the diagram is the user entity, which represents the individual interacting with the chatbot. The chatbot entity is responsible for processing user requests and responding accordingly. It may have attributes such as chatbot ID, language model, and response algorithm. The conversation entity represents an ongoing interaction session between a user and the chatbot, including attributes like conversation ID, start time, end time. Each conversation consists of multiple message enhanced exchange between the user and the chatbot, forming a answer user queries including frequently asked questions, products, details, or user specific information. The knowledge is dynamic and can be updated by administrator entity, which is responsible for maintaining the chatbot content and ensuring the system is running smoothly. In 5.4, there is a DFD diagram of the chatbot. In the first step, there is a user. In the second step, user connects with manage user information, which is connected with user information. User connects with managed type of loans, which means user has currently used a chatbot or not, or they have a previous record or not. User connection are from different monitor and manager applications, check for updates or anything, checks user satisfaction. If the user get their answer completely, it can be solved, or if the user did not get the answer or have some queries, then they again ask the question and the query will be solved. In the chapter 6, there is a system design. System design. In a system design, there is a data dictionary and database. Data dictionary is description, stored information about the user interacting with the chatbot. Attributes, user ID, username, password, email, preference, data type, and many more. In a message table, table name, description stores all the message sent by user and received from the chatbot. Attributes, attributes have a message ID, user ID, message content, timestamp, and data type. It all stores all the information about the user message table. There is a third point, conversation table. In the conversation table, representing ongoing or historical conversation between the user and the chatbot. In the conversation table, it stores the conversation between the user which they are currently chatting or have any history of the conversation which they already used. In a chapter in a point 5, it is an administrator table. It stores information about administration who manage the chatbot. It means there is an admin ID, username, their password, their data type. It is where comes under a administration table. There is in a database, relationship database file, SQL based, no SQL based files, backup and log files. It is all comes under a database. Database is a chatbot system that plays a critical role in managing the data model for various functions such as user interaction, message processing, knowledge retrieval, and system maintenance. Types of database used in chatbots are relation database, it is called SQL, no SQL database, in-memory database. Benefits of using a chatbot is centralized data management, personalized personalization, scalability, and consistency. In chapter 7, we will study about testing. Testing defines the clear test scenarios. Happy path test ideal user interaction where the vote works as expected. Negative test the test with individual input, typos, and ambiguous queries. Edge cases try usual log message, emojis, or mixed language. In a testing, there are some also points: functional testing, convergence testing, performance testing, integration testing, NLP model validation, automation, logging and debugging, accessibility testing, user feedback and monitoring. uh, there is a point 7.2 which we call test plan. Test plan overview. To validate the chatbot functionality, performance, usability, and reliability. Covers all chatbot features, include their intent recognition, response accuracy, contextual understanding, integration, and user experience. Test plan is exclusion specify what won't be tested. Example, unsupported platform, future features, and many more. Features to test: core functionality, feedback mechanism, integration, user experience, and performance. From chapter 8, we will hand over to the Karan Dahayat user interface.
Thank you, Shivanjay. There is a screen in the chapter 8. This is our first screen of the chatbot AI where the user asks their queries to the chatbot and they response their answer of their queries. And now we are turned into chapter 9, which is test limitation future enhancement. Limited understanding of context issue. Chatbot often struggle with nuance of complex context, especially multi-turn conversation. Example: difficulties maintaining context when users switch topics or reference earlier part of conversation. Second, lack of emotional intelligence. Third, dependency of training data. Fourth, limited problem-solving ability. Fifth, misinterpretation of input. Six, limited personalization. And seven, reliance on internet and APIs. Now, the 9.2 is a future enhancements. There is a point advanced context handling. Enhancement enable the chatbot to understand and retain multi-turn conversation construct better. Implementation, emotion recognition and response. Implementation, multiple interpretation and implementations. Now we turn on the our last chapter, which is conclusion. Conclusion is basically the potential of chatbot technology is vast and ever expanding, from enhancing customer service and providing 24 into 7 support to transforming industries like healthcare, education, and finance. Chatbots are already providing their value across a multiple of sectors by layering advanced AI, natural language processing, and machine learning. Chatbot can engage user in dynamic potential ways, improving efficiency, reducing cost, and creating new opportunity for innovation. Thank you so much.
Thank you so much. That's all for the today's presentation. Thank you.